Yes, it is time to get going. Well, the public cloud. Who has heard about the cloudy stuff that's going on? Yeah? Okay. Well, what is that thing, huh? So I'm going to talk about that. My name is Robert Schweikert. I'm a public cloud architect at SUSE. You can reach me there, rjschwei@opensuse.org or rjschwei@suse.com. And you will find me. What a great place for a conference, huh? OpenSUSE conference. See, as a speaker, we get to drink beer. Everywhere else I speak, I have to drink water. So, this is really cool. Anyway, what I'm going to talk about is, what is this public cloud stuff to begin with? So I'll give you an overview. Most of that is probably new. Not new to you, sorry, but I will talk about it anyway, and hopefully not bore you to death. I will talk about the big three providers that are currently the leaders in the field. Then, of course, there will be the question, well, okay, so there's this cloud stuff. How do I use it? We'll talk about that. And then, of course, what does all of this have to do with OpenSUSE? Right? It is cloud after all, and as we heard this morning, or just after lunch, during Aaron's keynote, there is actually concern, and rightful concern so, that when everything becomes a service, where does this leave free software, right? So we'll take a look at that, and we'll also look at the, what I consider the new vendor lock-in. We'll take a bit of a historical perspective of where vendor lock-in came from originally. Obviously now we're in this period where vendor lock-in is not as bad as it used to be, and it appears we're moving back into a time with the public cloud where vendor lock-in may once again become a much bigger concern than it is currently. And we'll talk about that and see, and I'll provide some of my thoughts about that. Okay, so what is this beast, the public cloud? What does that even mean? So a public cloud basically is it's one or many data centers made available to you, everybody. To you and everybody in the world over a public network, i.e. that internet thing. Everyone uses the cloud already, probably. Well, you use Google, Gmail, or G+, you use Facebook. Those are all cloud-based applications or cloud-based services. There are others, of course, Amazon.com, and so on. So the list of services that we use today, pretty much anything on your mobile phone, the list of services that we use today is endless, and all those services are cloud-backed. What I'm focusing on more, though, is not those services that are made available to us through providers that we either pay or we get spammed with advertisements so that the service is free. What I will talk about is what is known as IaaS, Infrastructure as a Service. Basically, a data center, a remote data center, where somebody else owns the hardware, and you're running virtual machines on that hardware. So infrastructure as a service. And that infrastructure as a service available over a public network, i.e. the internet, that's basically what we define as the public cloud. So what does it mean, though, when we say you run a system on somebody else's hardware on top of a hypervisor? Well, if you think about it and say, well, in the end, you are still the system administrator, right? It is only infrastructure as a service. So whatever runs on top of that infrastructure is made available to you through the internet, you have to administer in some way, shape, or form. So that means, well, it's pretty much the same that if you have a box sitting next to your desk, right? You have to put an operating system on that machine. You have to put applications onto that machine. You have to make sure the network is secure. You have to make sure you can log in. You have to make sure that the applications that you're running on that machine inside that VM are doing what they're supposed to do. So you need to look at monitoring those services that you're running for your company or for yourself, and so on. And so infrastructure as a service basically says, okay, you no longer have to worry about exchanging hard drives or busted memory or connecting it to the right power outlet and whatever else. Those are all those things that are taken care of by the cloud provider for you. But everything from there up, that still remains your responsibility. Basically, you are the system administrator. And for companies, that means the systems administrators that work at companies that maintain data centers no longer just maintain data centers, but they also maintain, well, data centers in the cloud. So basically, instead of exchanging hard drives and pulling network cables, now they're ramping up and down virtual machines in a cloud framework. And that's really what infrastructure as a service is all about. And so basically, as I say, you have to treat the running server just as if it were, well, your laptop or the machine under your desk or the rack server in your server room. Okay. What is really nice about the infrastructure service model, of course, is that it is pay as you go, right? So many companies today, you can walk around and you can say, so how much does it cost you to run a rack of servers or one server in a rack? And most companies will not have an answer for that, right? Which is surprising considering that, you know, in this day and age, all companies are very cost sensitive. And you would think somebody would sit down and say, okay, what does it actually cost for me to run a rack of servers or to run one server in that rack, right? I mean, you could think, well, okay, so the equation should be relatively easy. Well, you had to buy the thing, right? It's going to last for a certain period of time. You're probably going to have to replace some hard drives, and you should know what the power consumption is. So those are all things that are reasonably quantifiable. But then you have to go and say, okay, well, but I need a person to bring it in, I need a person to set it up, I need a person to connect it to the network, I need a person to manage, I need blah, blah, blah. And so the pay-as-you-go model at infrastructure as a service is nice for companies because it provides at least as part of that cost equation, a fixed cost, right? Amazon, Google, or Microsoft, they go and they tell you, if you run a virtual machine of size X, for 1 hour, it's going to cost you X amount of money. Cents for some machines and dollars for other sizes, right? So that really goes from a couple of pennies per hour to $8 or $9 per hour, depending on the size of the instance that you're using. And so for companies, that provides a certain convenience in that they can say, okay, when I run this server for X amount of hours, this is exactly what it's going to cost me. No more and no less. And then depending on where the data goes, either in or out, then you know exactly how much data charges you're going to have and so on. So by the end of the month, the company gets a bill and says, okay, this is what it costs you. And they don't have that actually when they run their own data center, which is very interesting. I find, anyway. And so that gives a certain momentum to the public cloud. Companies will not necessarily save money, but fixed cost that is in your data center today turns into operational cost that is predictable. And that's worth money to companies, okay? So it is interesting from that perspective, and that's why you also see more and more workloads, more and more companies moving into the public cloud. The other thing, of course, it's easy and fast, right? Once you have an account set up, you log in, you fire up a machine, and a few minutes later, the machine is up and running. And then you go, you put your application on it, you configure it, and, well, if you're clever, you have a Puppet or Chef Server or CF Engine or Ansible or whatever, and then it gets configured automatically once it's up, and off you go, right? And so this is much faster, obviously, and if you have to go, you have to buy a new server, you have to put it in a rack, you have to install it, and so on. So there are big advantages to the public cloud, and this is why the public cloud has such big momentum. okay? But the public cloud is more than just infrastructure as a service. The public cloud is also services, okay? All public cloud providers, and I will talk about them, the big three, in some more detail later, they offer services, such as database services, okay? So I could be connected to a database that actually runs in Amazon right here from my laptop and use their database service. And the database would actually be stored as a service at Amazon or Google or Microsoft, okay? So there's much more than just, they're providing much more than just letting you fire up virtual machines, right? So there are services in the public cloud that you can take advantage of. And this is not just software, but also storage, okay? So you can store your data there on disks, just as if you would in your data center, okay? What's really beautiful, of course, is that these companies that do this, they invest billions of dollars in data centers around the world, okay? Amazon has 9 regions, 9 connected regions currently. Google has 3, Microsoft has on the order of 15, and they're everywhere, right? And so you can actually store your data relatively locally to where you are. And even if you have business centers in different parts around the world, you can still be relatively local to those, okay? And then there are tons of smaller vendors that are really local, that are, based by country. I know there's cloud service providers that are just focusing on Germany and France and other countries. So they all exist, okay? But there are massive resources around the world. Obviously, the big companies, they will have bigger data centers, in many more locations, but that depends on how you want to use their services. So now I've talked a bit about providers already. Let's dive in a little more deeply in those. So the big boys here are clearly Amazon, Google, and Microsoft. The next layer down, I would say, is probably HP and Rackspace, and then there are many, 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 many smaller providers. Those you could say, oh, look at that, there's a typo. Providers, that's interesting. I don't think that's even a Dutch word. Anyway, there are many smaller providers. And as I said, so they may be country focused or regional focused, like maybe some may be focused for Europe, and those I don't really deal with, so I don't have much to talk about those. So, Amazon currently is the biggest provider, as we know. As I mentioned, they have 9 connected regions. There are 2 disconnected regions. One is in China and one is a data center they just run for the US government. Amazon basically created the market of the public cloud. They were the leader. They've been there first. Contrary to a popular belief, it was not created to use up access capacity for Amazon.com that they didn't need during the busy season. That was not the reason that Amazon Web Services was born. Amazon Web Services was actually born from the idea that you should be able to use computing as a service. And by the relentless drive of Amazon to make pretty much everything available as some kind of API. It is estimated that they have about 80% of the market at present. Others are catching up. The market is growing, so those numbers are certainly very fluid. For the first time this month, Amazon actually reported separately the revenue for Amazon Web Services, which is their division that makes that produces the public cloud, if you want to call it a product. That was reported at $1.57 billion for the first quarter of this year. So that's not shabby when you think that you can run an instance for a mere 2 cents an hour. Yes, and there are instances that cost $8, but if you think about it, that you can run, I could say, okay, I can run a web server for a couple of bucks a day. That's not shabby. That's a lot of money. And of course, they have customers that run completely on Amazon. Netflix is probably the best, one of the better examples, okay? Netflix owns basically no hardware, okay? While they own the desktop computers of their engineers and other things. But Netflix owns no servers. Everything that runs through a server that is served comes from Amazon. Everything. Netflix has made this move many years ago, and although there were hiccups, and some of them well documented, this is running like a well-oiled machine now. I mean, the times when you go to Netflix and you get movies not available, or the movie is hanging in your stream, those are very seldom now. So Netflix is a really good example of, what you can do in the public cloud. Amazon also, as being the prime mover, they have the most services, okay? As I mentioned, there are database services, storage, various storage services, data analysis services. Everything is being offered in the public cloud now as a service, and more services are being announced, by Amazon. Last year at Amazon reInvent, which is the Amazon Web Services Conference, they announced the container service and a source integration service, continuous deployment service, and things like that. So more services are being announced by Amazon. And also, they're bringing new data centers online. Nobody knows ever where and when they show up, but there's always, they're always expanding. Then we have Google. Google is probably the number 3 in the market at this time. Google actually entered the platform as a service market first, which is also cloud, with Google App Engine. And most of you will have probably heard that. And Google App Engine was actually running for, I would say, 2, maybe 3 years before Google entered the infrastructure as a service market. The infrastructure as a service offering that Google has is called Google Compute Engine. They're really driving towards simplicity of setup, simplicity of the interface, simplicity of the user experience. And they're investing a very big effort to catch up with Amazon and Microsoft at this point, as far as features is concerned, okay? Google's stability is fantastic, certainly as good as Amazon, and it is a very nice platform to work with. Then there's Microsoft, which is currently probably the number 2 player, okay? And here what is interesting is that we get a lot of customers running Linux on top of, well, Microsoft, right? Of a proprietary operating system, which is kind of mind-boggling in a way because, well, why would you run Linux on top of something that is not Linux in an environment that's even more expensive than when you can go and run Linux on top of Linux and be cheaper? But it is amazing, and basically Microsoft gets a lot of pull, right? Microsoft gets pull because they're embedded in the enterprise, okay? Those same systems administrators that administrate Microsoft whatever on the desktop, they have a relationship with Microsoft and they trust Microsoft. And so that trust continues into the cloud. So when that company that is embedded into the Microsoft ecosystem wants to move into the cloud, and even if they want to run Linux, they will move to Azure. So Microsoft is getting a big benefit from their 20, 30-year history of being a dominant player in the IT industry. They are now taking that benefit, reaping that benefit, as people are moving into the cloud. Whether this will continue that way or not is anybody's guess. I will certainly not comment on that. However, there are issues with the Azure framework. It is not as stable as the other two. And well, there are currently not really any good maintainable command line tools from our perspective, from a distribution perspective, okay? And that makes things a bit difficult. All right, so after this, let's look at how do you use this baby? How do you use the public cloud, okay? So first of all, you will need an account. Some kind of an account is needed, and that requires a credit card, okay? It is a service that is not powered by advertisement. This is a service that is powered by the plastic in your wallet. And so they're going to want money for it, but you only pay what you use, okay? So if you sign up and you put in your credit card and you fiddle with it for an hour, you'll probably spend $1. Boo-hoo, right? There are people that use the cloud as their backup, right? They store gigabytes of data for a couple of bucks a month. So it is not like, you know, if you give them your credit card, you're going to be in for an arm and a leg. You're not. It is really cheap. It is really cheap to try out, okay? Generally, there are two ways to access this baby: from the command line or through a web UI. And here we go. Now we're connecting this to Opensuse. For Amazon and for Google, we have the command line tools in OBS. They are developed in the Cloud Tools project, and everything is in Tumbleweed, and some of those things are also in Opensuse 13.2. We just didn't get everything into Opensuse 13.2, but everything is in Tumbleweed. So you can manage stuff that is in Amazon and Google right from the command line just by installing the AWS CLI package or the Google Cloud SDK package onto your Tumbleweed installation. Or you can get them for Opensuse 13.2 from the Cloud Tools develop project. Okay. Microsoft has decided, for better or worse, to build their command line tools on top of Node.js. And Node.js is a framework that is not really maintainable from a packaging point of view, because the way Node.js has decided to put all this stuff in one tree and do it over and over again with many different versions, and it's not really maintainable. We spend a lot of effort trying to make that work, and we came up to the conclusion that we're going to start a new project and write command line tools for Azure that can actually be maintained. And there's going to be a new project that the public cloud team at SUSE will announce in the next 2 or 3 weeks. Those will be written in Python, simply for, well, one of the reasons is that all the other tools are also written in Python, and so we can take advantage of some dependencies that are already maintained for the other tools. Okay, so here's a Google Compute Engine example, okay? Well, basically, this is all you need on the command line to fire up and shut down a machine. So you can just, gcloud is the command, then compute is the subcommand. You give it a project, SUSE GCE test, for example. This is one of our test projects that we use for our image testing for SUSE. Instances, that's what we're doing. We're creating an instance. We tell it the zone. Google has 3 regions and 2 or 3 zones within those regions. Europe West 1B is one, for example, here. You tell it how big of a machine you want. In this case, N1 standard 1 is a 1 CPU box. And then there you go. You say image Opensuse 13. And that will always point to the latest image that we have released. So in this case, I would launch an Opensuse 13.2 instance, and then I give it a name. Then once that fires up, you run gcount compute, and then you can SSH right in through the gcloud command. And then when you're done, you delete it, and that's it. So with one simple command, relatively simple command, you can fire up an Opensuse 13.2 image or instance in Google Compute Engine, right? Once you have an account and everything is set up. So this is really easy, and it is very similar to that for Amazon. Okay? And so now we'll look at Amazon, and we will see how well this is going to work. If I do that. All righty. Woohoo! Okay, so there you go. Yeah, I was hoping for a little faster connection, but... All right, so then of course I already have an account, so I would log in to AWS Management Console, maybe. Here we go. Is that right? Schweikert. No, right. Now you see another email where you can find me. All right, and now the Amazon Web Console loads, and here you can see all the services that they offer. Okay. Don't do that. Okay, so you can see here at the top left corner, I hope you can read that, there's EC2. So EC2 is the infrastructure as a service offering they have. Stands for Elastic Compute Cloud, so 2 C's, EC2. Then Lambda is a service that was announced last year at Amazon reInvent in Las Vegas. Lambda allows you to run code directly in the cloud, where you no longer have to fire up a virtual machine, you don't have to do any of that. You just write your code and you submit it and it runs. How nice is that? Lambda currently only works with JavaScript, Node.js, basically. What happens, of course, in the background is that once you submit your code to the cloud, they do all the magic for you. So they fire up a virtual machine and they inject your code and they run it, okay? But as far as your user experience is, well, the code just runs in the cloud, right? So currently this is Node.js. I'm sure that in the not too distant future they will make this available for other languages. I would consider scripting languages to probably be the prime target. The next one down you can see Ec2 Container Service. A container service is that you have an image that already has Docker installed, Docker daemon is running, and then through this container service you can interact with the Docker daemon that is running inside of that machine. So now you can run a virtual machine and then you can run Docker containers inside of that virtual machine, okay? Then S3 is a storage service, then they have multiple storage services. You can see they have multiple databases. Then there's networking services, and on and on and on and on, okay? You can see now they're starting with mail service as well here. Workmail is a preview. And so now I'm just going to show you real quick how we're going to fire up a, oops, where did it go? That one, yep. Okay, so we'll do EC2. Oh, sorry. I guess, all right, that's better. Yep, cool, thank you. Okay, and here you can see, up here on the right, you can see I'm currently operating in the Northern Virginia region. This is US East. And here, if I click on that list, you can see all the 9 regions that Amazon has around the world. So these are the integrated regions, okay? So you have stuff in Asia, here in Europe, in Frankfurt, that was the latest data center that was opened, and then 3 in the US. And so if I go, and I'm going to say, okay, I want to pick one that's closer to me, so we're going to go switch to Frankfurt. Come on, okay, here we go. That's basically, it's going to reload the console, which looks exactly the same as it did for US East region. Okay, you can see I have no running instances here. And so if we go and launch an instance, okay. So the first thing that happens is that the quick launcher is displayed, and you can see, there's SUSE Linux Enterprise. So these are the companies that Amazon works directly with, SUSE and some others. And then Amazon has their own Linux distribution that is available within Amazon. But of course, we're at the Opensuse conference, and so we are going to look for, Opensuse, here we go. And you can check those out. And now we're just going to see Opensuse images, okay? And you can see there's an Opensuse 13.2 image. That one was released in 2014, 11/26. So November 26, which is right around when the release came out, we also pushed images into Amazon, okay? So generally, the team that is helping to maintain these images, the image builds, which are in the project Cloud Images, we try to match the release cycle with these images, okay? So here you go. There's a 13.2 that was released on early November. There's a 13.2, and then there's a 13.1 image you can see. So you can see we're trying to keep up to date, and when there are big security issues, then we try to update these images as quickly as possible so that when you launch them, you get something that is not vulnerable right out of the box. If I then select this baby, then you go through some screen, you can select the instance types, and here you can see Amazon has the most instance types, so it goes from 1 CPU all the way down to, I think 16 is currently the biggest. Yep, there's a 32 actually now, so you can see you can launch instances that have up to 32 virtual CPUs with 60 gigabytes of memory and lots of storage and 10 gigabyte network connection, okay? So that is SR-IOV. The Opensuse images are currently not enabled for that yet, but we're working on that. And then you would just go through the steps, and eventually you click and you can launch one of those. So we can do that. We'll just run with a micro instance. You edit the security group, which basically says what ports should be opened. So you can connect. I have one configured here that is basically only opens the SSH port. Now I did that again. All right. And then you can review and launch. And then you can kick that baby off, and then it will run. So there's my key pair. Which, funny how that is named, and then it goes. And so now I'm running Opensuse 13.2 in Amazon Web Services. And if we wait for a minute, then you can see it is now pending and loading, and then it will run, and then I could log in via SSH. I can install Apache or whatever. I can open port 80, 443 or whatever, and then you can run your services there, all on top of Opensuse. The Opensuse images have our standard repositories pre-configured, okay? So everything that the updates and release repository, source repositories and all those are already pre-configured in the images. If you need stuff from the build service, then you just have to add those repositories as you usually do with Opensuse 13.2 or 13.1. And that's really it. See, now it's running, and theoretically I could log in. You can see it has an IP address, a DNS name, and so that could be used to log in. I'll spare you the small print of my terminal. Okay, so with that, Amazon, that was Amazon. And then, so what does this have to do with Opensuse? Well, as you saw, Opensuse is already in the cloud. So we have Opensuse Images in 4 public cloud providers. Okay, Amazon, Google, HP, and Microsoft. And basically what we do is I get to piggyback and take advantage of the position that I'm in at SUSE and say, okay, well, if I'm doing work for SUSE, we're also going to take the same accounts and we're going to release Opensuse Images, okay? So that way, but I'm not really in any way special. Anybody can really do this, and anybody, well, you can't use the SUSE accounts, obviously, but you can build your own Opensuse images and you can upload them to whatever cloud framework you want, and you can customize those images, okay? As I mentioned, the images are maintained in the Cloud Images project, which is in OBS. So they're built with Kiwi. There's a configuration file for Kiwi. You can see the package list that goes in there. You can see all the quote-unquote magic that we're doing to get the stuff running in EC2 or Google or Microsoft. You can take those and you can derive your own packages, or you can help us maintain these. And if there's something that you think should be in the base images, feel free to send a submit request or let me know, and we'll be happy to, put the package in if it's something that is generally useful, right? What we want to do though with these images is make sure that they remain base images. So, we're not going to want to release a new image that has, well, the whole Ruby stack or all of Python. Then they become too big and cumbersome and it really makes no sense, right? So the customization and installation of the stuff that you want in is really up to you. Okay. I already mentioned we have the standard repos configures, and the images, we try to get them refreshed when there are major security issues. Heartbleed comes to mind. Everybody remember that? Heartbleed comes to mind, shell shock, things like that. Then we try to refresh the images. Or if there's a bug discovered in the initialization code, which may lead to boot failures or things like that, then we release new images. Or if we have functionality issues, right? If we forgot to include, let's say, the network stack, which would be important because in the end the machine is running remote, and if there's no network stack, well, then you can't log in, and that would be really bad for a machine that is thousands of miles away. And so if that happens, then obviously we're going to refresh the images and release them. Okay. As far as packages is concerned, so each cloud provider has their own special sauce. Okay, that means they have special stuff on how they treat a running instance, how they initialize, how the instance gets initialized, and how stuff gets in it. Okay, so as far as stuff getting in it, one thing that's important obviously is, well, your SSH key. Again, logging into a remote machine is really important because, well, the machine is remote. If you can't log in, then it's kind of useless that it's running there to begin with. And so how the SSH key gets injected and stuff like that, that is really, well, it's different per cloud provider. Okay, one tool that seems to be emerging as something that's coming around to be somewhat of a standard is Cloud Init. And we do use Cloud Init for Amazon today. We are looking at using it for Azure and eventually Google, but Azure and Google do some other stuff with their initialization tools that Cloud Init doesn't want to do. And so the intermixing of those tools is still a problem. And so currently for Azure and for Google Compute Engine, we're only using those initialization tools and not a mixture. So we package all those initialization tools. Again, those are all in Cloud Tools project. You can look at those. And of course, we package the command line tools where they're available, and hopefully in the not too distant future, we will have the beginning of a maintainable Azure command line tool set. So with all of that wonderful things, let's not ignore the things that are not so pleasant about the public cloud, what I call the new vendor login. Okay, so if you go back a while, if we take it trip on the Wayback Train. Way back when, we all started with computing. Well, some of the younger folks here didn't, but I'm on a little older side. And way back when, well, what happened was you got everything from one vendor, right? So the IBMs and HPs of the world, they sold you the box, they sold you the operating system, they sold you the software that was running on, and they sold you the services to set it all up. All wrapped up nicely in an expensive package and said, here you go. Plug it in, plug in the network, and run it. And that was wonderful. Until you decided that, look, now I have all this wonderful equipment here from this company, but I really like this other company better today. Well, now you had a problem, right? Because those things didn't talk to each other, and you tried to move your data, and well, so you were pretty much locked in. The next step, of course, was generic hardware, Linux, no vendor lock-in, well, less vendor lock-in, right? We still have some issues. Standards in databases, SQL, and things like that, so you can transfer your data around. So there's a lot less of this today than we used to have. Now, if you look at what I just showed you, and if you think of, hold on, there are these guys out there, they give me database service. And exactly, you're going back to where we came from. So, the new vendor lock-in. So, things remain reasonably portable if you stick to the base images supplied from OBS, or build your own, or whatever, right? This is not OBS specific. If you stick to your own images, you build your own web front end, you run your own instance that is the database backend. When you do those things yourself, you remain reasonably portable. Of course, you're still storing all your gobs of data in the cloud, right? Because you're running your web service there, so you're going to store your data there. And it's going to cost you an arm and maybe 2 legs to get your data back out. But because you're running the database and you're running everything, you can get your data back out relatively easily, right? So if you stick with the basics, you're reasonably portable, right? You have an Opensuse image in Amazon, and you can configure the Opensuse image in Google just the same way, right? Be it through configuration engine or doing it manually, and you can certainly transfer the data from point A to point B. Costs money, but it can be done. Okay, so now you're reasonably portable. In this case, of course, you only depend on the web UI or the CLI tools, and well, you can learn a new web UI, or you can learn a new command line interface. So, you know, that's not really that big of a deal. However, and of course, you know, data out costs money, but it can be done and it's not so bad. But now, okay, things are not supportable once you start using the services of a given cloud provider, okay? So once I use the database that Google offers to me, or Azure, or Amazon, well, now I am depending on their database. And now, of course, well, yeah, SQL is SQL, but we all know it doesn't really work that well, right? We know that I can't take the exact SQL script that I have, well, to a certain extent, of course, but we all know that doesn't work that well, right? Once there is an extension, people will start using it because it gives you a little faster data transfer, or because it does a little bit of something nicer, right? So once you start using these extensions or whatever, then, well, SQL is no longer SQL, and I can no longer just go and take the database, the data that is stored behind the database service in Cloud Framework A, and stick it into Cloud Framework B, right? So once you start using these services, database service, data analysis, even storage to some extent, because that doesn't necessarily match one for one. You've seen in the Amazon console, they have 4 storage services, right? Almost nobody else has 4 storage services. They have 1 or 2, so that there is not a 1-to-1 match, right? And so now, once you start using those extra services, now you're basically getting back into the vendor lock-in, right? There's a vendor that gives you everything nicely wrapped up in a bow, and yes, you can. Yes, you can get it out. But it is going to be just as hard as 20 years ago when you decided to move from hardware vendor A to hardware vendor B's box. It is going to be almost just as hard, okay? And so this is where there is a danger for free software, for us, open source developers, right? We develop a lot of this technology that is behind of these services. That technology that gets wrapped up nicely in a web front end, that is proprietary. Obviously, all these command line tools are open source because we can distribute them through packages, right? Most of them are Apache 2 licensed. But they get wrapped up in this nicely proprietary web front end, and then once you stick your stuff in and you use these services, well, then you're kind of locked into that service, okay? And so making those decisions, you people have to think about how important or not important is this vendor lock-in, right? I've had conversations with many people about that, and from what I hear, many people really don't care about that much, which is surprising to me considering the history where we came from to the point where we are today. Okay, and with that, food for thought. If you have any questions, I will be happy to try and answer them. Yes, and if you can wait for a microphone, then I can actually hear you. And others as well.
Yeah, if we have command line tool for at least two vendors, then how hard it will be to migrate from one vendor to another? Even if it have some specific services, maybe it's also possible to somehow migrate it.
Right. So if you operate the stack by yourself, right? So if you just take a basic web application and you say, I'm going to run my database in an instance that I control, and I run my Apache front end in an instance that I control, then migrating that is easy, right? All I have to do is fire it up in some other cloud framework, set it up exactly the same way, push my data from point A to point B, and shut where I'm coming from down. Easy. But as soon as you start using those services, well, now you have a different problem, right? Because I can't just get a hold of the SQL file in point A because I don't control where it is, right? I have to run a SQL dump, store that somewhere in that cloud framework, then pull all of that down at once, right? I can't connect those services to each other, right? If I control everything, I can connect both of my databases at the same time, and I can run a sync, right? But if I don't control the whole stack, if I use those services, then I have to do, well, a SQL dump. But if I do that, what happens? Well, that service is still running, so I'm getting new data. So now I have a problem, right? Because I can't start syncing the databases because they're a service and I have no control over that. So now I have a problem with migrating, right? And that's where you get into a lock-in, potentially into a lock-in situation. Of course, if you're willing to say, okay, for the next 2 hours, I'm going to shut down my service, I'm going to take a SQL dump, I'm going to download it all, push it over here, upload it all, do a SQL import, and if you have gigabytes of data, it's not going to be done in a couple of hours, right? Then you're fine. But if you have to keep everything running, and you use a service that you're not under control, that you can connect, then you have a problem, right? You're locked in, essentially. Other questions? Okay, then. Thank you very much. Thanks for your time.